For the function f of x equals 4x plus 6, express the slope of the secant line in terms of x and h. And then we have some other parts there, but we'll wait on that. What I want to do is talk about the secant line first. I want to give you an idea what the secant line is. So a secant line is when you have a curve, let's say this curve here, and you're going to choose 2 points on that curve and then draw a line connecting those 2 points. So that line that's connecting those 2 points, that is the secant line. The secant line is a line that passes through 2 points on the curve. So what we want to do is we want to find the slope of that line. So let me show you how we'll express that line. We're going to say that we have this first point being x, f of x. That's an x and a y value. I've used x and f of x because it could be any point on that line. And then a small distance away from that point, so if we're thinking on our x scale here, this is at a value of x, a small distance away from that point, that small distance is h. So this other x value will be x plus h, x plus the small distance. Then the y value at that point, so here's our y scale, the y value at that point will be f at that x value, x plus h. So we're going to be able to find the slope of the secant line by using our normal slope formula. Our normal slope formula is to take y2 minus y1 over x2 minus x1, except we're going to use these ordered pairs that we have here. So the one ordered pair is x f of x, and the other ordered pair is x plus h and f of x plus h. So we'll use for y2 f of x plus h, for y1 f of x, for x2 that's x plus h, and for x1 that's x. And with a little bit of simplifying in the denominator, we get f of x plus h minus f of x over h. So this is the formula that we're going to use to calculate the slope of the secant line. And you may also be familiar with this because this is the formula for the difference quotient. So for part A, let's find the slope of the secant line. So f of x plus h would be 4 times x plus h plus 6. Let me give myself a little bit more space. It's 4 times x plus h plus 6 minus f of x, so that's minus 4x plus 6 all over h. I'll use the distributive property on this 4, and I'll also use the distributive property on this negative. So I have 4x plus 4h plus 6 minus 4x minus 6 over h. The 4x and 4x cancel, the plus 6 and minus 6 cancel, leaving me with 4h in the numerator and h in the denominator. Those h's cancel, leaving me with 4. So the slope of the secant line is 4, and that's a constant. Now, with a little bit of thinking about this, it makes sense that that slope is a constant because f of x equals 4x plus 6 is a straight line. It has a y-intercept at 6 and a slope of 4. So if we take 2 points, any 2 points on this line, and try to draw a secant line, we're going to end up with the slope that is the same as the slope of the original line. So because our function f of x is a straight line, the slope of the secant line is a constant. But if our function were a curve instead of a straight line, then our slope would be changing. The slope of the secant line would change based on the points that you choose. For part B, it says find the slope of the secant line for h equals 0.5, 0.1, 0.01 at x equals 1. So this is a unique problem because our slope of the secant line that we found is a constant 4. So it's not dependent on what h is, and it's not dependent on what x is. So the slope of the secant line is going to be 4 for each one of these situations. So the value of the slope as h approaches 0 will be 4. For part C, find the equation of the secant line at x equals 1 with h equals 0.01. So to find the equation, we need to know the slope and a point on the line. So we already know the slope is 4. The slope of the secant line is 4. And we want to find the point where x equals 1. If x equals 1, f of 1 is 4 times 1 plus 6, and that's 4 plus 6, which is 10. So I'll find the equation of the line using the point-slope form. Y minus y1 equals m times x minus x1. So I'm using that point, 1, 10. So in for y1 is 10, in for the slope is 4, and in for x1 is 1. That's y minus 10 equals 4x minus 4. I'll add 10 to both sides, and I have y equals 4x plus 6. So the equation of the secant line is 4x plus 6. So finally, I'll graph the original function, 4x plus 6, as well as the secant line, 4x plus 6, in the same viewing window. And we see that the two are actually the same lines. So this happens because our original function is a straight line, and because of that, the secant line is the same as that function. Thank you for checking out my videos. Have a great day.